And we're ready to look at worksheet 6C, not to be confused with extra practice 6C. This is for the Math 4 course. And yeah, I've actually I've been talking about my Math 2 course lately that right now I'm teaching them about sine, cosine, and tangent, and SOHCAHTOA and all that sort of thing. And of course, the big heartache that is, when you discover that your mode has been in radians all along. We've had many conversations about that. All right. Basically, these questions are largely the same, but you'll notice that they differ by the kind of information that they ask about. And what I wanted you to do was to screenshot whatever you could put together as a graph, and then respond to the question: what is the typical birth month for students in North Carolina? All right, so let's do him at a half screen like that, and let's bring on this guy, and I'm going to have to do a partial screen with him too, just so that I can see what's going on here. Now, we had talked about this, I think, last time, that here's this chart with like 40 columns all the way from left to right. And when I first started doing this, it's like I'd stretch to the right and then drag it to the left, and then stretch to the right and drag it to the left. And I've since discovered that I can do this switch to case card view in the corner, and it will just give me a list of all of the categories. And all I really want is the name of them. For instance, when we're saying what is the typical birth month, so I'm going to look at birth month. And we're going to drop him into the x-axis. And we get some dot plots, so I thought, all right, let's use the dots and the bars. As a matter of fact, just to make it easier on ourselves, let's show percent. So there's percentage up above. Now, if I stretch this out a little bit, it makes it a little easier to read. And I can tell that January was 12%, November was 11%, anybody else is below 10. So as far as this is concerned, I'm going, let's see, I think I have to first turn on I can get a hold. I'm not going to be able to get a hold of this. No. This is driving me nuts. Okay, I finally figured out how to drag that from behind. I've got like a little toolbar for my recording, and everything I needed was hiding right behind it. So anyway, all right, so typical birth month we're going to say is, we're going to start with January. And maybe November. Those were the two leading candidates. You had what, 12 and 11%, and so that should be enough for number one. Number two, we're looking at favorite activity, so we're going to get rid of this guy, and we're going to start a new graph, and we're going to find favorite activity. Oh, that's outdoor activities hours. Well, didn't take me this long last time. Favorite food, favorite school. How am I missing this? I keep forgetting his favorite physical activity. All right, and I'm going to stretch this out a little bit just to give us a little bit of elbow room there. And I think I'm going to do the same thing to this one. We're going to fuse the dots into bars, and I'm going to do percent. And I can barely see the percent up at the top. Stretching it down doesn't help. Maybe if I stretch it this way. Yeah, it makes it a little easier to read. And again, you need to do a screenshot of this into your worksheet. But we're noticing that other is 15 and soccer is 13, and everybody else is well below 10. And so, we're going to make note of that. And I find myself asking the question, why is other so large? I mean, Lord knows they gave you 20 different sports to choose from. And they were talking about physical activity, so it's not, I don't think that playing Fortnite counts as a physical activity. People may be getting physical in the midst of it, but I don't think that's what the survey had in mind. Now, it occurs to me things like weightlifting is not on the list. So, there are people who enjoy lifting weights. They're not doing it for football or basketball or whatever. They're just, looking to better themselves. So, there are some other options involved here. So, um, but that gives us a way of, finding an answer. What is the favorite activity? Uh, the favorite activity seems to be something other than these 20 things they've listed out. But aside from that, soccer seemed to be the most popular on the list that we did have to work with. So those are the kind of answers that you can come up with there. Now, favorite food. Um, let's see now, we're going to X out of this, and we're going to grab another graph, and we're going to look for favorite food. There it is, right there. And they had a variety of categories here. And it seems that our biggest one was pizza and pasta. Oh, big surprise there. All right, we're going to fuse our dots into bars, and we're going to show percent. And so, that you've got 21% that, you've got 18% meat. Well, think about that. Pizza and pasta represented 21%, and meat represented 18%. That's 39%. That's almost 2 out of every 5 respondents right there with those two categories. So, and I guess meat, can be steak, can be chicken, could be fish. I guess sushi would qualify for that. But in any case, so that's the way that we'll look at the data. Although they did have seafood as a separate. Well, let's look at our categories. Seafood is a category, so I guess fish and sushi would fall under that. Poultry is chicken, so I guess meat has to, well, does it have to be beef? It can be pork, it can be lamb, all of those categories. I personally am not a huge fan of lamb, but anyway, there's just not enough mint jelly on the planet as far as I'm concerned. But anyway, all right, so that is our response there. And you'll notice that we keep using these bar graphs and looking at the relative frequency, the percentages of how often they occur. But one thing that you'll notice along the bottom is that they're all categories. There's not numbers here. It's like, pizza and meat and fruit. They're all categories. There's not a numeric continuity across the bottom here. So that's what that's going to look like. And like I said, screenshot it and paste it over there onto your page. And it's all right if yours looks a little different from mine. That's okay. I have to presume that with the wide variety of options that CodeApp gives you, that some people are going to maybe not fuse them into bars, maybe not view the percent, and that's fine. You can look at just the stack of dots and say, ooh, he's the biggest one. All right, typical number of text messages sent. So let's look that one up. We had an interesting conversation in class about that. And I guess this is sent yesterday. And 600, 700, 800, really? Somebody sending 800 text messages inside of 24 hours. Now, I didn't calculate that much in class. I think I used 600, but somebody said 800, and so I got to go there. 800 divided by 24 means 33 an hour. That's basically a one text every 2 minutes for the entire 24-hour period. So let's say that they got 8 hours of sleep. 800 divided by 16 is 50. So that's more like a text every minute. And I mean, for your entire waking hours, 16 hours a day, a text every minute. That's insane. That's somebody that needs an intervention, really. But anyway, all right, we're going to stretch this out. I tell you what, I am going to show you something. I feel like these out here are almost ridiculous. I would question whether they really happen that way. One thing you can do, that if you feel like data is not realistic enough to include, that somebody's pulling your leg, you can drag a box over it like I did. Now they're all green. I can go up to the eyeball and I can say hide selected cases, and they're gone. Now I've got this huge wide open gap on my graph, so I'm going to go up here to the box with the arrows, and it's going to say rescale it. So we're going to shift the scale, and now it looks more like that. Now I find it interesting that you have some bits and pieces along the way, but you have a stack of them at 100 and 200 and 300 and 400 and 500. So they're people that tells me people that are rounding. They didn't look at their phone and see that they had 543 texts yesterday or something like that. They're saying probably 300. So I think that's guessing there. Now here we don't have the option of doing bar graphs, because these are not categories; these are numbers along the bottom. So I tried looking at them as grouping them into bins, and so that's like from 0 to 100, and 100 to 200, and 200 to 300, and so on, which that kind of gives you an idea. I'm going to ungroup them and go back to points, because quite honestly, this was showing us about as much. Now, two things that would be interesting would be mean and median. And the mean should not surprise you being over here to the right. The median represents, the exact middle. There are just as many people below that number as there are people above that number. So median of 30, here, looking at this graph, looks quite reasonable. Now, the mean, remember, is the average. And remember, you had all these 400 and 500 that were dragging the average toward the right. Now, that's what we called skew right, because it's on the right side and it's skewing. It's dragging the average in a direction that is not necessarily a good one. You have a handful, you have less than a dozen people up here that are dragging this center to the right. It's a difference between 30 and 68. That's almost double. And there's a part of me that says that, I don't know that these, when you talk about atypical, we're talking about somebody in the middle, aren't we? And I feel like these guys represent the extreme rather than the average. So, we're going to mark that the median was 30, but the mean was 68. But we suspect mean is affected by a handful of high data items. Those 400 and 500 that were dragging the average in a direction which wasn't really a good one. So I'm more inclined. I guess I can't change my colors here, but that's probably the one we're going to go with. As I say, typically 30 text messages a day by your average youngin. All right, so we're going to move on to the next one. What's the typical height of a student? Now we're going to run into some similar issues here, because again, you're noticing that we're not dealing with categories anymore. We're dealing with something that is, measured in numbers. Now, I want to point out something. We wrestled with this in class earlier today, and we figured out that this data point right here, 265, that is 8'8". And I'm sorry, I'm not willing to buy the fact that somebody 8'8" was in school, not in high school. College maybe, but not at high school. So that's one that we're going to hide. So that's not affecting everybody. And then we're going to reshape. And that's a little better look at what we're dealing with. Now, look at what happens when we do mean and median. You almost can't tell them apart. I literally have to drag it down this way to where I can get between the two. The mean is 169.5 and the median is 170. All right. And I'll say this, when you have both the mean and the median landing on the same number practically, that's an indication that you've probably found the middle. That's the way that you really, that makes your job easy when that happens. And when you look at this, these guys are pretty well spread out in your typical bell curve. They really are. So, screenshot that and maybe even, have the mean and the median in there, to show that they're in the same place. But again, stretch it out large enough to where you can tell the difference, because when it was back up here like this, you could barely tell one from the other. They both look purple, not red and blue. All right. So that's number 5. Number 6, typical number of languages spoken. Now this was an interesting one that we did in class. Let's see now, languages spoken, there it is. And look how they all clump up there. Now I'm going to say this. I don't see somebody speaking 30 languages in high school. No, that's, not unless you are some genius that memorizes everything you touch, much less 178 spoke. I think there's barely 180 countries in the world. So I'm going to take these two and I'm going to hide them because I think that somebody's pulling our leg. And so with all the space left, I'm going to reshape this thing. And oh, that is so much nicer. Although the thing that bothered me with this is that I could not get it to look at just, points. This is a whole string of points, and I couldn't get it to tell me how many. These are all these now, even a bar for each point. Let's see what happens when we do that. Wow. Okay, that's an interesting effect. And we can still do mean, median, and standard deviation, but the thing you're going to discover, I'm going to undo this. Because again, I'm not getting a sense of, we have a relative sense of where they are. That definitely the majority speak one language, and there's a lot that speak two, and there's only a precious few that speak 3, 4, and 5. Now watch what happens, even when I do mean and median. The median is going to be over here because apparently at least the first half are all one language. But the mean is at 1.47. Now, watch what happens when I do this, standard deviation. Remember, we said that 68% of our data points should fall within one standard deviation, plus or minus. And that's what's happening here, is that my mean is 1.47, 1.5 languages, if that's possible. And then my standard deviation is 0.69, so that would be 1.147 plus 0.69 and minus 0.69. So you might as well say 1 and 2, And so, perhaps our response is that, most speak 1, many speak 2, and then there are a few that speak more. That may be our best response to this. Three or more. And I might even say a few. That's probably a better description, is to say that a few speak 3 or more. All right, let's move on. How long does it take students to travel to school? All right, so we're going to X out of that and bring up a new graph and travel to school. I have a feeling that's back toward the beginning. Yes, there's travel to school. Oh, that's how you travel to school, not how long. Travel time. Okay, that's what I should have grabbed, was travel time. And once again, because time is a number, you don't have categorical data here. You have numeric data. You have quantitative data. And those were the two that we kicked out last time. I don't see the need to this time. However, I'm really wondering about these that say they traveled 90 and 100 minutes. Now, I'm going to leave them there because, I've lived in the rural areas, not just Wake County. As a matter of fact, I can remember that, my grandyoungins would get on the bus in Johnson County and they'd be on the bus for an hour and a half. So I'm going to leave those in there because they're realistic, although they are probably most definitely outliers. So let's see what happens when we do mean and median. Now the mean is, the median is 10. So your average kid spends 10 minutes on the bus, which, wow, that sounds like a lot less than what I'm used to around here. The mean is 14. So, we got to decide, are we going to do that? Are we going to maybe do a box plot? Oh, no, that's an interesting look, where you've got your highest value all the way over here, but most everybody lives down there. Now that would be something worth reporting. Q1 is 7, median is 10, Q3 is 15. So I got 7, 10, 15. So I could say so you're basically saying here that at least half of the students that you surveyed fall within 8 minutes of each other, between 7 and 15. That's represents half of the data right there. And the very middle of the data says 10. That sounds reasonable to me, and if you did mean and median and you put through mean in there and the mean was 14 versus 10, they're not that far off from each other. So your outliers here didn't affect the timing, but so much. So, we can feel reasonably comfortable about either answer as being arguable. So, all right, and then, screenshot whatever you've got and put that there. All right, number 8, typical number of hours of TV watched by students. This also led to an interesting conversation in class. Travel, TV, watching TV hours. Now, this highest value right here is 54. And I did a little mental math in class earlier today, and I said, if somebody spent 12 hours a day on Saturday and Sunday, and then 6 hours a day Monday through Friday, that's your 54 hours. So that's basically what they're saying, is that they, when they're not in school, they live in front of the TV, which is scary. But you'll notice that most everybody is somewhere between 0 and, say, 10 hours. Matter of fact, I would say the lion's share is probably 5 and under. And it's beginning, I'm beginning to wonder if this is a valid question anymore. Because not that many people watch, TV. We're not talking about, watching Netflix on their phone or their tablet or something like that. We're talking about regular TV, regular cable channels and such. And it's become a dying art form, as it were. You probably a more valid question is going to be video games, which I think they've got that as one of the questions. But anyway, moving on. Here we can do things like, let's look at mean and median and see what's going on there. And again, they're both real close here. Median is 3, mean is 5.5. And I think, again, it's some of these weirdos here that are way out to the right. This is definitely a graph that skews right. Okay, it is the people to the right that are dragging the average to the right. It should be closer to 3, but now it's 5.5 because of these guys out here that have no life. So, yeah, Mrs. G is over there giggling. They have no life. They need to go to Kmart, find the flashing blue light, and get a life. But anyway, and look up Kmart flashing blue light if you have no idea what I'm talking about, because that's entirely possible. It was a thing from the 70s and 80s. I guess you had to be there. All right. So, are we going to look at something like a box plot? Are we going to look at something like standard deviation? Now, that's interesting. That gives you everybody, the mean is at 5.5. and the standard deviation is 7.6. So that's 5.5 and 7.6 is about 13.1. And so, 68% of the data falls between 0 and 13.1. So, 2/3 of your kids watch, say, 13 or less hours. And as you're looking at this, the lion's share of it is over here on the left side. So, maybe the median is not such a bad thing. You could actually make an argument for both. Let's go ahead and say median is 3 and the mean is 5.5, and there's definitely a skew right going on here. There are some kids that are watching way too many hours, and it's throwing off the class average. We may, these kind of situations, we tend to lean toward the median, feeling like that represents the true middle of the group and not, including the influence of the weirdos. So anyway, I know, I use weirdos as a term for anybody that's outside of the middle group. All right, you're outliers. All right, I know. This is giving me dirty looks, but anyway. Let's see now. What is the relationship between foot length and age? Now you're going to notice something changing with these last 4 because we're looking at 2 different variables. That's going to change the whole picture right there. So, all right, let's grab a graph, and we're looking at foot length, which is this guy. And we're looking at age in years, and we're going to put that on the y-axis. And you're going to know, well, first of all, I'm going to take this guy. Somebody who is 50 years old, that is either a teacher who doesn't belong in this survey group, or it is a youngin who is just pulling our leg. So, but the thing that I noticed is that, we had a lot of responses in the age group of 16, 17, and 18. Even when you spread this out. And the other thing, you'll notice that they had a tendency to cluster at 21, 22, 23, 24. You've got all sorts of people that when you ask them how long their foot is and they break out the ruler, they're going to give you a round number. They're not going to give you 23.5. Somebody did. Somebody's trying to be hyper accurate, but most everybody is willing to go with a whole number. So you'll notice that a lot of these are clumps like that. And even if you drag this down that way, and I need to get out of that. Okay, I hate it when the Babylon Bee interrupts me with a new headline. But anyway, you're noticing that, you've got all of these dots, and even if I stretch this some this way, my other, it still looks consistent. The clusters are at whole numbers, and they stretch all the way from 11 to 18. And remember, each one of these dots represents one youngin. So and then you've got the dots down here on the end. Now there are some that are not in the clusters like this, are up at the top of the graph, as it were. And again, this is the kids that are 16, 17, and 18. So they apparently had more responding. And those that were older had a tendency to respond more accurately. That's an observation. That doesn't answer the question, what's the relationship between foot length? Well, I don't know. Maybe that is a relationship that you say that older students tended to respond more accurately. It's kind of funny because, there's a part of you that would think that, as a child gets older, their foot would get longer. But this is not the case. You've got enough respondents on all these different lengths that there's not really a relationship between age and length. Not here. Now, what we are noticing from the data is that there is a relationship between how accurate, do they just give you the response in a whole number, or do they give you a decimal? The 16, 17, and 18-year-olds have more of a tendency to give you the decimal than the younger crowd does. So I don't know how that makes it a relationship between foot length and age, but that is something that we've noticed with the data. So that's other than that, there's not really any trends or anything like that you can mark for that. All right, favorite season and birth month. Well, this should prove interesting. Let's see if I can get this. I'm stuck again. Hang on. Okay, I finally got rid of that other one. That's the thing about I'm recording this on a window within the screen. I don't have the full screen. You're not seeing my full screen, so sometimes stuff gets hidden that I can't click on the thing that I need to, and I got to figure out how to get to it. Anyway, all right, so we're talking favorite season versus birth month. So let's bring up a graph, and let's see now. There's favorite season. So let's do the favorite season on the y-axis that way, and then birth month. It's easier for us to spread things out horizontally that way. Now, let's see what kind of tools they give us for this, because it's been our experience that when we have these multiple bar graphs like this, they usually don't let us do much. All right, we can do percent. All right. Wow. I'm just kind of looking at all of this, trying to figure out where we're going with this. I mean, we remember the fact that January and November were the most popular birth months. But now when we start talking about winter, I'm noticing that there seems to be, it's either the fall or the summer, because there doesn't seem to be a lot of response in spring, and there doesn't seem to be a lot of response in winter. So I think it's safe to say that fall and summer are more popular. Now, just in looking at, for summer, December babies and June and July babies. Well, the June, July babies doesn't surprise me. You have your birthday in the summer, so your summer's your favorite anyway. And meanwhile, fall for those born in November, that's not a surprise. September, October, that's not a surprise. So, perhaps, and when we look at even the favorites in winter, that's January, that's December. There does seem to be a trend here. In spring, let's look at spring. Your biggest one was September in the spring. That doesn't match. January, April, somewhat. Spring, apparently not many people chose spring to begin with. So, we might consider that spring may be, but we noticed that with winter and summer and fall, it seemed that when their birth month fell during that season, that was their favorite season. So let's describe it as some correlation. Between birth month and season during which birth month falls. All right, I'm on 40 minutes, so I need to go ahead and wrap this up. All right, relationship between hours of TV watched and number of paid work hours. Okay, so TV watched and well, you can almost guess where that's going to go, but let's see what it looks like as a graph. All right, number of hours of TV watched. I'll throw that on the X. And then paid work hours. Okay, maybe I better switch these, put the paid work hours down here. And it's automatically going to switch watching TV over here. Now, I'm going to stretch this out this way. There is a little bit of a cluster over here. Of course, there's a lot of folks that, just simply didn't have a job, 0 paid hours. But you'll also notice that they were the ones watching the, 40 and 50 hours of TV. Now, there was somebody over here that said that they got paid, they worked for 40 hours and they watched TV for 40 hours. They're not going to be in high school unless, they're claiming that they are watching TV while they're on the job. That's a good way to get fired in most cases. And we're noticing some, like here's one. They work 15, but they watch TV for 30. They work for 20, but they watch TV for 30. I find myself questioning that because if they are, they're not doing any schoolwork whatsoever. They are flunking out. Because when you stop and think about it, you are in school. Well, you might have as many as 8 hours a day. You might have 40 hours during the regular week, in addition to your school time, and that includes things like meals and social time and that sort of thing, and getting whatever homework done. I don't know, but in any case, let's kind of notice that there's a steady stream of folks that are not working and watching a lot of TV. And there's a scattered response out here. Now, I will say this. You're not, well, nobody's going to work 100 hours. That's just not happening. That's, as a matter of fact, you can practically take those two off. Hide those two. And it is going to stretch it back out. I question whether these were telling the truth. I guess we'll put it that way. There's a relationship between low work hours and high TV hours. That much we can point out, and we're questioning high work hours and high TV hours. I just don't see how you can do both and graduate high school. All right, last one. Relationship between number of text messages sent yesterday. We've already looked at that some, and a student's age. All right, that is it a question that the older they are, the more text they send, possibly. That's going to be my guess at this distance. So text messages sent yesterday, and then age, which is up here at the top. All right, that's an interesting cluster. Let's stretch this out this way a bit. And I seem to recall that we had knocked out those. Let's see what count does. Count doesn't do anything. I don't see anything. And I'm not going to get into connecting lines and movable line. We're not looking for plotting an average here. We are noticing that there is a huge clump down here, and probably there appears to be more. As a matter of fact, let's do this. Let's get rid of those so that we can see this group here spread out a bit more. Excuse me. Again, you have a tendency for them to use round numbers like 20 or 30 or 40. Or 100. But remember, the higher you are on the graph, the older you are. And I'm not sure that I'm seeing any real relationship. They seem to be all over the map. I was expecting an idea that the higher ones would be the older kids, but that is not necessarily the case in this. I'm having a hard time distinguishing. Well, let's see what happens just for funsies. Let's look at this group down here. The only thing that I can point out here is that the respondents tended to be older when they gave a specific number like 22. If they tended to round it and just say 20, 25, 30, they gave you a rounded figure, they tended to be younger. So, maybe that's something that we can respond like we did with one of the last ones is that the older they are, the more specific their answer was. And you're expecting a trend. No trends, except older students tended to give answers more specifically. And not just round numbers like 20 or something like that. And I did not need to do that. There. All right, and I think that is going to cover the last of our questions. So I apologize for this going long like this, but sometimes you got to talk the data through and just look for relationships anywhere that you can.